Hello, welcome to this lecture on process control, Laplace transform, chapter 2, part 25. So in this, I'm going to discuss about another forcing function, which is known as terminated ramp input. I have already discussed about 5 forcing functions, 5 commonly used forcing functions. Now, in this, we'll see another forcing function, known as terminated ramp input. And if possible, if there is time, we'll solve a problem from a previous year GATE question paper. Well, what is a terminated ramp input? We know ramp input. Ramp input is a function. A ramp function is one. Ramp function is also known as linear function. It is one which varies linearly with time, or also we can say a function whose value changes at a constant rate. The slope is constant. So that is linear input. For example, in this figure, this line, if this line goes continuously, it is a linear input. But here what happens is, this line is halted, is stopped at this point at time t equal to t naught. This variation, linear variation, or the ramp function, is stopped at time t naught. That is, this ramp input is terminated at t naught. So it doesn't vary afterwards. It does not vary after the time t naught. Till t naught, it varies linearly with the time, or it varies at a constant rate m. At constant rate m is a slope. At t naught, the variation is terminated, and afterwards it has a constant value this. Afterwards it has got a constant value this. So this is known as terminated ramp input. Now we have to write equations for this, and as usual, as is the case, since there are two parts of this curve, one from 0 to t naught, it is straight line, linearly changing, and after t naught, it is a constant horizontal line. So we need to have two mathematical equations to describe this forcing function. So the equations, first for the period t between 0 and t naught, that is in this region, t greater than 0 but less than t naught. So in this region, it is a simple linear equation. It's a simple linear equation, or the equation of a ramp function. So f of t equal to m into t, right? So this is for 0, t between the period 0 and t naught, t less than t naught but greater than 0. It's a simple linear equation, m into t, and the Laplace transform of this is m by a square. M by a square. Well, now let us consider the period t greater than t naught. So in this period, for example, let me consider here, somewhere here. Now let us consider a time corresponding to point C. So let us take any time t corresponding to point C here. So let us consider a time t which is greater than t naught. So in this period, t greater than t naught, let us consider point C where time is t. And the value of the function for t greater than t naught is this line, constant line. So now how do I get an equation for this? Now if the function does not terminate here, so let me imagine I continue this function, continue this straight line. So dA is a continuation of straight line, and AC is a vertical at C. Now let us, so what is the equation now? So for t greater than t naught, here f of t equal to, what will be this? The value of f of t corresponds at point C, that is for t greater than t naught at C. Let me take at C here. So f of t will be equal to the value BC, right? Value of f of t at this time tc will be equal to BC. And what is BC? BC is nothing but AC minus AB, right? BC is AC minus AB. Now what is AC? Point A is a point on the straight line. A is a point on this straight line. A is a point on this straight line. So AC, the value of AC will be equal to straight away m into t. So A being a point on the straight line mt, so AC will be equal to mt. Now what is AB? AB, I know here AB by BD is the slope of this line. AB by BD is slope of the line. AB by BD equal to same slope m. AB by BD is slope of the straight line m. And BD is what? BD is, if you see the figure here, BD is t minus t naught. BD is t minus t naught. So AB will be equal to m into t minus t naught, right? So I'll write here AB equal to m into t minus t naught. So this is the equation for f of t for t greater than t naught. Is it understood? So for this period, for the second period, t greater than t naught, f of t equal to m t minus m into t minus t naught. So this is the equation for t greater than t naught. Of course, if you simplify this, the numerical value will give you what? M into t naught. So that's the numerical value of this function for t greater than t naught. If you look at the figure at C, at any point t greater than t naught, the value of the function is this. The value of the function is this, right? The value of this function is this. And what is this? This value is nothing but the slope into t naught. Slope into t naught will be this value, right? The value of the value at t d is this value. We see here, this value is going to be m into t naught, right? This value is going to be m into t naught. Here is m into t naught, this value. So the numerical value of the function is, if we simplify this, m into t naught. But we cannot take the numerical value of the function alone as the mathematical equation. We need an equation which takes into account the immediately previous history of the function, because this mt naught is not constant for all the time. It didn't reach a constant value for a long time. It has not been constant for a very long time. It has been changing from 0 by a linear equation and then halted, terminated at t naught at t equal to t naught. Afterwards, it has become constant. So we need an equation which will describe not only this value but the immediately preceding history of this function. So that is why these two equations, mt minus m into t minus t naught. Though the numerical value, but the numerical value will be, just for verification, is going to be mt naught. So these are the two equations for this curve. One for t less than t is f of t equal to mt, and for t greater than t naught, f of t equal to mt minus m into t minus t naught. Well, what is the Laplace transform of this? Laplace transform of this function f of s, Laplace transform will be equal to mt. We know mt is m by s square, and m of t minus t naught is the same as translation of function e power minus st naught. So if we take m by s square common, 1 minus e power minus st naught. These are all s. What I have written is small s. Yes. So this is the equation for the second part for t greater than t naught, which I got by this detailed method. For easy understanding, I have taken this method BC equal to AC minus AB, etc. Now I'll give a very simple method of finding this equation for t greater than t naught. It's a very quick method, no need for all these equations. Now this is a ramp function, linear function up to t naught. So up to t naught, the equation is mt, and if it further continues, the equation will be mt only, but it does not continue, right? So it is stopped. So from this equation mt, you have to subtract mt. Followed. I am trying to find the equation for the second part t greater than t naught by a very quick method without any equations. So this is mt, right? Mt. But it does not continue. At here it is terminated. Here it is terminated. So the equation for this period is f of t equal to mt. If it continues, it would have been mt, but here it is terminated. So I have to remove this portion. So minus mt. I have to remove this portion. From here it is terminated, so I have to remove this mt. So that's what I have done here, mt minus mt. But not only remove, but I have to add this portion, right? I have to add this value. It is going to be continue at this point, right? It is going to continue at this point. So I have to add that value. It is going to continue at this point. I have to add that value. What is that value? This value, I told you earlier, this value is mt naught. This value is mt naught. So I have to add this value. So simple, that's all. So once from this value, from this equation, I have to remove that minus mt, and then I have to add this constant value. So if you do that, I get the same equation. If you take this mt, and if I take these two terms together, m to t minus t naught. So this is the equation for t greater than t naught, which is the same as before. I hope you understood this. Well, I'll stop this lecture with this. The question from previous year gate we'll solve in the next lecture. We'll solve the gate question in the next class.